Today we are going to look at section 10.7, polar coordinates. This is found in your textbook on pages 745 to 748, and you may want to read through the pages on your textbooks because this is a new topic. It's going to be something that you guys are unfamiliar with, and so it may benefit you to also read through the text. Let's take a look here at polar coordinates. So the polar coordinate system is just a different way of representing a coordinate point. Up until this point, you guys are used to using XY, rectangular coordinate points on an XY coordinate graph. That's what you're used to. So this is a whole nother coordinate system. You can see what it looks like here on the right. So a polar graph, instead of being, squares and rectangular, is made up of concentric circles centered around something called an origin or pole there in the middle. So you can see that. And instead of being an XY point, it's now an R theta point. So R is the directed distance from the origin to the point that we're looking at. You can think of R as being how many circles you're counting out on this set of concentric circles. So you can also think of R as serving as a type of radius for the circle. Theta then is the directed angle counterclockwise from the polar axis. The polar axis starts at the origin and extends out to the right. It's kind of like our positive x-axis. So that's the polar axis that I just highlighted there. So let's look at this example point real quick. So here's my point, circled it, okay. Notice that it's 1, 2, 3, 4, 5 circles out, giving it an R value of 5, and from the polar axis around, it has an angle measure of 2 pi over 3. So this point is the point 5, 2 pi over 3. As we go throughout this lesson, we're going to talk about, which I'll show you here in a second, how to represent polar points multiple ways, just due to the fact that we're looking at circles now and they repeat every 2 pi. You guys are used to that. We're going to look at different ways to represent polar points as well as converting back and forth between polar and rectangular. So we can still represent this same point as a rectangular X and Y point, and so that's what we're going to look at today. So here are a few different ways you can represent polar points, and it's all using what we know about the unit circle, so you can keep the R value the same and either add or subtract multiple circles to get the same exact point. It would just be multiple rotations of the unit circle, or you can negate the R value and then add and subtract half circles, and it's also going to give you the same point. So we'll talk about what a negative R value does as we go throughout the examples. Let's look at the first one here. So first we are going to plot the polar point 3, negative pi over 4. So 3 is my R value, meaning wherever this point is, I'm going to be 3 circles out from the origin or from the pole. Okay? Theta is negative pi over 4. So here's my polar axis. Keeping in mind, if you have a negative angle is going to go clockwise from the polar axis. So I'm going to move pi over 4 clockwise from the polar axis to get my angle, which is putting me at 7 pi over 4. Okay, and I'm going to go 3 circles out toward this 7 pi over 4 to plot my point. So there would be my point. Circle it there for you. So that's your point. In the book, they typically go ahead and put a line connecting out the point, but it is really just that point there. Okay, so that's my point 3, negative pi over 4. Now let's look at 4 additional ways to represent that point based on those formulas that I showed you on the previous slide. So first one says we can keep our R value the same and then take theta and add 2 pi. Well, what's that going to change my point to here? So I'm going to keep 3 the same. If I take negative pi over 4 and I add 2 pi to it, I get 3 7 pi over 4. So 3, 7 pi over 4 is the same point as what I just graphed here, which makes sense. I went 3 units towards 7 pi over 4. Okay? Let's look at another one. So I can do r theta minus 2 pi. That would give me the point 3, so r is staying the same. Negative pi over 4 minus 2 pi is negative 9 pi over 4. So that's just saying I go around the circle 2 pi and another pi over 4, same exact point. So let's look at a third one. This time I'm going to negate my r value. So negative r theta plus pi. So I'm going to negate it, negative 3. And then if I take negative pi over 4 and add pi to it, I get 3 pi over 4. So let's talk for a second about like what that means. So 3 pi over 4, that's right here, up here. The negative 3 means instead of going towards 3 pi over 4, I went 3 circles away from 3 pi over 4. So 3 circles backwards away from 3 pi over 4. That's what a negative r value is. And let's look at a last one here. Negative r theta minus pi gives me the point negative 3, negative 5 pi over 4. And so negative 5 pi over 4 would take me the whole way around up to here again, and then it's 3 away. So that's 4 different representations of this same point. You can do as many as you want. Just keep doing this again, adding 2 pi again, subtracting 2 pi even more from what you have, and you can get as many representations as you want. Let's do another one. So let's plot this polar point, negative 2, 5 pi over 6. So we're looking at this negative r value again. So that means I'm going to go 2 away from whatever my theta value is. So my theta value is positive 5 pi over 6. So instead of going 2 circles towards that, I'm going 2 circles away from pi over 6. 5 pi over 6, excuse me. And my program doesn't like me making dots, so let me see here. Let me get a highlighter and kind of try to highlight. So there's my point right there, okay? And again, you can draw a little line to it if you want, but you don't have to. Get back on my pen. And so there's my point there, negative 2, 5 pi over 6. Erase that big line so you can see it a little bit better. Okay, so there's my point. So now we're going to do our 4 additional representations of that, again going through those 4 same formulas. So the first one we're going to do r theta plus 2 pi. So I'm keeping my r value the same of negative 2. I can take 5 pi over 6, add 2 pi to that, and when you do that, you get 17 pi over 6. So there's another representation of the same point. Keep my r value the same, theta minus 2 pi. So keeping that negative 2. 5 pi over 6 minus 2 pi gives me negative 7 pi over 6. Let's do another one. So negate the r value, theta plus pi. So if I negate negative 2, that gives me positive 2, and 5 pi over 6 plus pi is 11 pi over 6. So let's take a look at our graph here a second. This should make sense. Notice that I'm going 2 circles away from 5 pi over 6, which means I'm going towards 11 pi over 6. So there's that point. And last one, negate my r value again. This time subtract pi. So I get a positive 2 again, and I get negative pi over 6. which again, that should make sense. Negative pi over 6, if this is my polar axis, that would put me at that 11 pi over 6. Okay, we'll stop there for this video. Next video that I'm going to do is going to be the conversion equations back and forth from rectangular to polar, and vice versa.